Hi friends, today I am going to explain about the module 1 topics. ARM core data flow model. It is a very much important and repeated video question. This contains a data which is to be addressed in the following way. The data entries through the processor core through a data bus, and data can either be data item or it can be instruction. Data contents will be stored in the registers register file that are not to R50, and if the data contains instructions that will be decoded by instruction decoder, then the ARM code reads most of the instructions are a data or 32 bits. If the instruction or a data is 8 bit or a 16 bit, it will be converted to a 32 bit with the help of a sign extender. ARM core has a two source registers that can be a RN and a RM, that is followed by A and B points. Then ALU and a MAC takes the values of RN and RM and perform the operation, store the result in the RD. The important features of ARM core is a barrel shifter. It preprocesses the register RM for load, store instruction, increments, updates, and address register before a core reads or write the next value from the memory. ARM core continues the execution of the instruction until exception or a interrupt. These processes will be asked many times in the video. It's a fixed question. It's very much important to learn in the microcontroller. CPSR means current program status register. It contains the fields that are flag, status, extension, and a control. These are the four fields, and which contains a number of bits that are total 32, and the functions which includes the condition flags, Zazzle state, interrupt marks, thumb state, and a processor mode. These are the functions and the bits and the fields. This can be explained in the way the R core uses the CPSR to monitor and control the internal operations. The CPSR is a dedicated 32-bit registers and resides in the register file. The CPSR is divided into four fields. Each contains a 8-bit wide flag, status, extension, and a control. In current design, the extension and the status fields are reversed for a structure. Then the control field contains the processor mode, state, and interrupt mask bits. The flag field contains the conditional flags. Some ARM processor cores have a extra bit allocated. Like example, J bit, which can be found in a flag field, is only available on a Zazzle enabled processor which execute 8-bit instructions. Then the processor mode determines which registers are active and the access rights to CPSR registers. Then the interrupt marks used to stop specific interrupt request from interpreting the processor. Conditional flags updates the comparisons and results of the ALU operations. The final one is a thumb state, indicates the processor current state.